for tonight. Ventilation. Ventilation is the systematic release and removal of heated air, smoke, and gas from a structure and replacing them with cooler air. Proper ventilation is not accomplished haphazardly. Inadequate ventilation can cause death or injury to fire victims and firefighters and cause destruction of the building. Firefighters must know ventilation principles and implement them promptly, thoroughly, and routinely. Properly done ventilation decreases fire spread and increases visibility for fire attack. To be successful, ventilation depends on careful planning, building construction knowledge, fire behavior considerations, systematically removing contaminants, coordinating ventilation with other activities. Reasons for performing ventilation: reducing heat levels, decreasing fire spread, reducing extreme fire behavior, improving interior visibility, improves victim survival, and reduces smoke and heat damage. Advantages of proper ventilation: aids in life safety, removes smoke and gases that endanger the occupants, promotes firefighter entry and improves visibility to speed rescue, and reduces risk of steam burns to personnel. Some more advantages: fire attack and extinguishment. Speeds attack and extinguishment by helping to localize the fire. Reduces fire and water damage by reducing the amount of water needed for extinguishment. Aids in fire spread control. Reduces mushrooming from heat and gases banking down and spreading laterally. If crews are not ready to attack a fire, even proper ventilation will add air to the fire and allow it to grow. Reduction in flashover potential. The potential for flashover is reduced by removing heat before flashover occurs. Ventilation can remove the heated gases which are heating the contents to their ignition temperatures. However, ventilation can also increase flashover potential by adding needed oxygen to a superheated area. Reduction of backdraft potential. Flammable gases are vaporized from the combustibles burning. Oxygen has decreased by burning. The admission of air can cause the burning of gases with explosive force. The intensity depends on the degree of confinement, the amount of heated gases, and the rate and volume of fresh air admitted. Carefully controlled ventilation must be done to direct the burning gases harmlessly and prevent backdraft condition. Usually, vertical ventilation is the safest way to vent a building with backdraft potential. Some backdraft indicators: confinement and excessive heat, heavily smoke-stained windows, smoke puffing at intervals, smoke coming through cracks, little visible flame, gray-yellow colored smoke, and windows rattling. Some more advantages: property conservation. Since proper ventilation speeds extinguishment, fire damage is lessened. With smoke and heat vented, salvage operations can start outside of the fire area, even while fire attack is progressing. Some ventilation considerations: the safety of the occupants and fire personnel must be considered before ventilating. Depending on fire conditions, ventilation may be needed before search and rescue operations. If necessary, the fire may need to be attacked first. Sometimes search and rescue is done simultaneously with ventilation. Potential hazards with the accumulation of smoke and gases: visibility impairment, presence of toxic gases and flammable gases, a lack of oxygen, potential for backdraft and flashover. The type and design of the building involved are key factors when considering what type of ventilation to use, such as the number and size of wall openings, number of stories and roof openings, roof construction, and built-in fire protection systems. High-rise. Vertical openings such as pipe shafts, stairways, elevator shafts, and air handling systems contribute to a stacking effect, where smoke and fire gases create an updraft and layer smoke on floors above the fire. Ventilation has to be coordinated with fire attack and rescue efforts. 4 to 6 times as many firefighters will be needed for a high-rise building compared to a residential fire. Ventilation may be accomplished horizontally with mechanical devices. Vertical ventilation in high-rise buildings may involve only one roof stairwell opening. Before doors on fire floors are opened, the door leading to the roof must be blocked open or removed. Using stairwells or elevator shafts for evacuation and ventilation simultaneously is ineffective and dangerous. Opening a stairwell at the top will draw smoke and heat into it and to anyone in it. The safest and most effective method may be to pressurize stairways with positive pressure ventilation fans. Basements. Access to a basement is extremely difficult without effective ventilation. Firefighters must descend through the worst smoke and heat to get to the fire. If a ventilation opening is made opposite the entry point, fire and smoke can be pushed toward the opening with ventilation fans. Windowless buildings complicate firefighting and ventilation operations. Windowless buildings usually require mechanical ventilation, which can spread fire. Personnel must also be aware of the steam created by firefighting efforts until adequate ventilation is established. Many tactical and ventilation considerations are based on the visible smoke conditions at the scene. Smoke conditions vary with the progress of burning. If plastic and synthetic furnishings are involved, the smoke may be very thick. Smoke can hide that the structure has become well involved in fire. Firefighters must remember that smoke is fuel that is not ignited. Airflow is air moving toward burning fuel and smoke moving out of the compartment. Some airflow indicators: velocity or speed, turbulence, the direction, and movement of the neutral plane. Airflow is caused by pressure differentials inside and outside the compartment. Differences in the density between the hot smoke and cooler air. Airflow follows a flow path: inlet where the air enters, flow path through the fire area, and outlet or exhaust where smoke and heat exit. With an open door, the air inlet is the lower portion of the door, and the smoke exhaust is the upper door portion. Venting before the fire is located can spread the fire. Fire can spread vertically through stairwells and shafts, partitions and walls, windows, ceilings and floors, collapse of floors and roofs, voids, concealed spaces, and ducts. The phase to which the fire has progressed is a primary consideration in determining ventilation procedures. Visual heat indicators: blistering paint, bubbling roof tar, crazed glass. Before ventilating a building, there must be adequate resources to control the fire because the fire may increase with ventilation. If wind direction permits, entry should be made as near the fire as possible. Charged hose lines should be positioned at the entry point so attack can be started as soon as ventilation is done. Hose lines must also be in place at points to prevent fire from spreading to exposures. The incident commander must determine which type and which means of ventilation are most appropriate for the situation. Type vertical or horizontal, and the means natural or mechanical. There is no rule for selecting the point to open a roof for ventilation except as directly over the fire as possible. Some factors to consider when selecting a vent location. Are there existing openings such as skylights, vent shafts, or hatches? What is the location of the fire and the direction the incident commander wants the fire to be drawn? What type is construction? Your wind direction. The extent of the fire and the building conditions. Melting or bubbling roof tar, and indications of poor roof integrity. Consider the effect that ventilation will have on the fire. Protection of exposures, and readiness of your attack crews. Weather conditions will affect ventilation. Wind conditions must always be considered when determining the means and location of ventilation. It can blow fire toward exposures. It can blow fire into uninvolved areas, and it will supply oxygen to the fire. Other weather factors which can affect ventilation: temperature, atmospheric pressure, precipitation, humidity. Internal and external exposures must be taken into consideration when beginning ventilation. Internal exposures such as occupants, contents, uninvolved areas. Rising smoke and heat naturally travel to the upper levels of a building and can ignite areas. External exposures will be affected by radiant heat and direct flame contact. Fire can be drawn into open windows and openings of adjacent exposures. Vertical ventilation normally involves opening the roof or existing roof openings to allow smoke and heat to escape. It allows for natural convection of heat and gases upward. It improves interior visibility. Horizontal ventilation is the venting of heat, smoke, and gases through wall openings such as windows and doors. Means used for horizontal or vertical ventilation. Natural. Opening doors and windows so natural air currents and pressure differences move smoke and heat out of the building. Uses the natural rising of heated gases to draw them out through the roof openings. Mechanical ventilation. Uses fans, blowers, and smoke ejectors. Most often used with horizontal ventilation. Can be used to pull smoking gases out and push fresh air into a structure. Hydraulic ventilation. Uses fog streams to draw smoke out a door or window. Requires the firefighters to operate the nozzle in the contaminated area. and can increase water damage if done improperly. Horizontal ventilation used in situations where the building is not heavily charged with fire and the attic is not involved, has high windows, is a multi-story structure, has large unsupported open spaces under the roof, is so weakened by fire that vertical ventilation is unsafe, has a daylight or walkout basement. Horizontal ventilation advantages. It is easier to accomplish than vertical ventilation. It may be more effective, and it may be used with other methods. Horizontal ventilation disadvantages. Cannot be used if backdraft potential is suspected. If not properly done, can draw fire in uninvolved areas. Always consider interior and exterior exposures. And opening extra doors and windows can disrupt ventilation. Does not require additional personnel or equipment, and natural ventilation can work if conditions are right, taking advantage of natural airflow. Open top windows on the leeward side and lower windows on the windward side, as shown in the diagram. Charged hose lines must be ready to attack the fire whenever horizontal ventilation is used. Mechanical horizontal ventilation can be used when natural ventilation is not sufficient. Mechanical ventilation advantages: more control of airflow, supplements natural ventilation, speeds smoke removal, and reduces smoke damage. Mechanical ventilation disadvantages: can increase fire intensity and spread, dependent on a power source, requires special equipment, additional resources, and personnel. Negative pressure ventilation uses smoke ejectors to pull smoke out of buildings. Fans should be placed to pull smoke out in the same direction as the wind. Air recirculating or churning around a fan can be a problem. Opening around the fan should be covered to prevent churning. Attempt to keep the airflow in as straight a line as possible to avoid turbulence. Avoid opening windows or doors near the fan. Remove obstacles to airflow. And only use fans with intrinsically safe motor when venting flammable atmospheres. Positive pressure ventilation. High volume fans blow fresh air into a building to create higher pressure in the building, which forces smoke out to lower pressure areas. Blower is placed 4 to 6 feet outside of the door so that the cone of air completely covers the opening. Smoke is ejected from another opening about the same size as the point of entry. Doors inside the structure may be closed to clear one area at a time. With multiple floors, fans should be placed at the lowest level. Positive pressure is directed by opening and closing doors. Additional fans can be set up on upper floors to increase airflow. Personnel must avoid standing in openings which could block the flow of air. Keys to effective positive pressure ventilation. Take advantage of the wind condition. Make sure the cone of air from the fan fills the entry opening. Reduce the size of the area pressurized to speed up the process. Keep the exit opening about the same size as the entry opening. Some positive pressure ventilation advantages can be set up without personnel entering the smoke-filled area. Can be effective with vertical or horizontal ventilation. Removes smoke faster than negative pressure ventilation. Heat and smoke may be directed away from unburned areas. Fans do not block means of egress. And can be effective in all types of structures. The velocity of air currents within a building is minimal with little effect on the contents or smoldering fires. The cleaning and maintenance of PPV fans is less than required for smoke ejectors. Heat and smoke is directed away from unburned areas. And exposed buildings can be pressurized to reduce fire spread into them. Positive pressure ventilation disadvantages. The structure must be intact. Fan exhaust can create higher carbon monoxide levels, and hidden fires may be accelerated and spread. Hydraulic ventilation may be used when other types of forced ventilation are not being used. Performed by crews making an interior attack after a fire has been controlled. A wide fog pattern is used and held about 2 feet from the window. The fog pattern should fill 85 to 90% of the window opening. Air drawn into the fog pattern will pull smoke out along with the water. Hydraulic ventilation advantages. Removes more than mechanical smoke ejector. Only a hose line is needed, and the water fog also protects personnel. Hydraulic ventilation disadvantages. Water damage may be increased. An increased drain on the water supply. In freezing temperatures, the amount of ice is increased. Firefighters must be in heated atmosphere during the hydraulic ventilation operations. And the operation may have to be interrupted when personnel exhaust their air supplies. Before ordering vertical ventilation, the incident commander must consider the need for ventilation, if it can be safely and effectively done, and the age and type of construction of the building. The location, duration, and extent of the fire, escape routes, where to ventilate, and how to move personnel and equipment to the roof. Hazards with vertical ventilation. The possibility of weakened roofs. It's time consuming. Some roofs may be difficult to ventilate. If it is not properly done, fire will be drawn to uninvolved areas, and personnel are working over the fire. Vertical ventilation safety precautions. Wear full protective clothing and SCBA. Observe wind direction and exposures. Work with the wind at your back. Note existence of holes, obstructions, or weights on the roof. Consider fire duration time factor. And consider type of roof structure. Provide a secondary means of escape. Secure a lifeline on roof or use roof ladders. Make sure a roof ladder is firmly secured over the roof's peak. Guard the opening to prevent falls. and evacuate the roof when ventilation work is done. Be alert for electrical wires and overhead obstructions. Keep other personnel away from those using axes and power saws. Start power tools on the ground, but shut them off before raising. Extend ladders 4 to 5 rungs above the roof line. Do not jump on a roof. Check the structural integrity of a roof before stepping on it and check it during the operation. Always walk on bearing walls and strongest points of the roof structure. If working from aerial ladder platforms, the platform floor should be even with or slightly above roof level. Be aware of the warning signs of unsafe roof conditions: melting asphalt or shingles, a spongy feel to the roof, smoke coming from the roof, or fire coming from the roof. Personnel must always work in teams of at least 2 on a roof, but no more than necessary to get the job done. Determine the integrity of the roof. The type of construction should alert personnel to the presence of truss construction. Look for obvious sagging or heat damage to the roof indicating possible weakened areas. Sound the roof to determine its integrity and the location of supports. Axe is held vertically with the top edge of the head downward. Top is then struck on the roof to allow the firefighter to hear the sound. Supported over rafters or joists and unsupported sections of a roof will sound differently when struck by the tool. Roofs with several layers of roof coverings may sound solid even though they may be weakened by fire. Rotary saws, carbide-tipped chainsaws, or ventilation chainsaws are faster and cause less damage than axes. Saw operators must maintain saw control at all times. The saw should be shut down whenever being moved. The roof ventilation team leader's responsibilities include maintaining constant communications with the supervisor, ensuring the roof is safe to operate on, ensuring that only the required openings are made, and working to minimize damage caused by firefighting operations. Coordinating roof activities with other firefighting efforts, overseeing the safety of all personnel assisting with the roof operations, and ensuring the team leaves the roof as soon as their assignment is completed. An inspection hole to help determine the fire's location and direction should be cut before ventilation hole is cut. A kerf cut is the fastest and easiest to make. A single cut is made with a saw or an axe. The hole size limits visibility of the conditions. Heat can melt roofing tar and seal the hole. A triangle cut can be made from a kerf cut if needed. Consists of 3 overlapping cuts to form a triangle. Always use a tool if the center of the cut must be pushed in, and smoke and sometimes fire will exit the cut. Offensive ventilation methods involves opening a roof over the seat of the fire or near the highest point of the roof. A square or rectangular opening is easier to cut and easier to repair after the fire. A large hole is better than several small ones. A ventilation hole should be at least 4 by 8 feet. Existing roof openings should be used whenever possible. These openings may not be in the best location or large enough for adequate ventilation. Some examples: skylights, dropout panels, roof monitors, roof vents, and scuttle hatches. Ventilating a flat roof. They're common on mercantile, industrial, and apartment buildings. Construction. Rafters can be wooden or metal, with parallel cord trusses covered with sheathing, maybe poured concrete, gypsum, or concrete slabs. Ventilating a flat roof. Confirm the order to ventilate the roof. Select the location for ventilation. Outline the opening with an axe pick. Cut the roof deck parallel to a roof truss or support on the side further from the ladder. Cut the roof deck on one side of the opening perpendicular to the first cut. Cut the roof deck of the opposite side of cut 1. Complete the ventilation hole by cutting between cut number 2 and cut number 3. Remove the decking from the opening. Working from upwind of the hole, open the ceiling under the opening by pushing the ceiling with the blunt end of a pike pole. If a truss is in the middle of the cut, a louver cut is used. A section of roof decking is allowed to be still nailed to the center rafter. This section is then tilted to create the opening like a louver. Make short cuts across the top and bottom of the rafter. Pitched roofs. Elevated in the center along a ridge with a downward pitch to the eaves along the roof's edges. Rafters or trusses run from ridge to walls for support. Sheathing or decking material is attached to the rafters at right angles and may be placed solidly over the roof or consists of boards or planks with a small space between them. When ventilating a pitched roof, watch for signs of heat. Be prepared for sudden truss failure and collapse of the entire roof. Confirm the order to ventilate the roof. Select the location for ventilation and outline the opening with an axe pick. Cut the roof deck across the rafters on the high side parallel to the ridge. Cut the deck on the further side of the ventilation opening perpendicular to the first cut. Cut the deck on the opposite of the second cut. And complete the opening by cutting the bottom between the two parallel cuts. Remove the decking with an axe or pike pole. Working from upwind of the hole, open the ceiling under the opening by pushing the ceiling with the blunt end of a pike pole. Arched roofs. Span large, open areas unsupported by pillars or posts. Bowstring trusses. The lower cords may be covered by a ceiling forming an enclosed cockloft or attic. They can hide fire long enough to weaken the truss system, and if one member of a bowstring truss fails, the entire truss will probably fail. Trussless or lamella construction enables all parts of the roof to be visible. Made up of relatively short boards of uniform length, and boards are beveled and bored at the ends and bolted together at an angle. Trussless or lamella arches forms an interdependent structural member network, and it is supported by buttresses or tie rods or both. These roofs can fail when one part of the network of boards burns through. Some trussless arch roofs use massive arches of steel, concrete, or laminated wood buttressed to the ground at both ends. Arches are connected to each other by horizontal members called purlins. A large hole can be cut or burned through this type of arch roof without causing collapse. The biggest problem in venting arched roofs is that the roof curvature prevents ladders from laying flat or being hooked onto the roof. Firefighters must sound an arched roof and walk only on trusses or strong points. An inspection hole should be cut in the roof to locate trusses and determine fire involvement under the roof. Concrete roofs. Precast concrete roofs are becoming more common. Lightweight concrete roof decks may be poured in place over form boards and steel roof decking, made of gypsum plaster and Portland cement mixed with other aggregates. Aggregates is a fancy word for gravel. Usually finished with roofing felt and hot tar. Breaching concrete roofs should be avoided. Some lightweight concrete roof may be penetrated with a hammerhead pick or power saw with a concrete blade. Heavier roofs may require a jackhammer or diamond tip chainsaw. Existing roof openings should be utilized before trying to open a concrete roof. Metal roofs may be constructed of light gauge steel decks, cold formed steel, galvanized sheet metal, aluminum. Metal cutting tools or power saws with metal cutting blades are needed to open metal roofs. Metal roofs on industrial buildings usually have roof openings, such as skylights or hatches. Trench or strip ventilation is used to stop spread of fire in long, narrow structures. A large hole or trench at least 4 feet wide is cut in the roof from one exterior wall to the opposite exterior wall. The hole is cut ahead of advancing fire to set up a defensive line. The advantage is to stop horizontal spread of the fire. The disadvantages: danger to personnel if the roof is weakened, takes a large amount of time to complete, and requires several firefighters. To be successful, personnel must plan ahead, maintain communications between the IC and roof team, always have situational awareness of the hazards involved, and have a charged line present. Have 2 means of escape from the roof which are remote from each other and do not cross the cut. Assign a roof safety officer to monitor conditions, and cut small inspection holes a few feet from the trench on both sides of the hole to monitor fire spread. Fire streams must never be projected down into a ventilation opening. Heat and gases can be forced down into the building on firefighters and contribute to fire spread. If streams are to be used to cool the thermal column from a ventilation opening, they should be operated above the hole and aimed slightly upward. Other factors that can disrupt effective ventilation: improper forced ventilation, excessive window breakage, breaking skylights, additional openings between the attack team and upper opening. Basement fires. Without built-in vents, ventilation of basement fires is essential to avoid vertical extension. If windows are available, these can be used for horizontal ventilation. Natural paths can be used if the smoke can be ventilated to the outside without endangering other areas of the building. As a last resort, a hole can be cut in the floor near a door or window and a smoke ejector used to force the heat and smoke to the exterior.
Daylight basement ventilation. Found in homes built on a slope with exterior windows and exterior doors. Usually easier to ventilate than conventional basements. Opening exterior doors and windows can provide adequate ventilation. Building ventilation systems effects. Heating, ventilation, and air conditioning, or HVAC systems, may draw in smoke and heat and spread fire. The system may automatically shut down when smoke or heat is detected in the air ducts, or firefighters may have to shut down the system manually. During overhaul, area around the system should be checked for fire extension. The system may be equipped with dampers or smoke detectors, which shut system down if smoke is present. Firefighters should not attempt to operate smoke control systems during fire conditions. Building engineers should be called to operate smoke control systems at the direction of fire personnel. Properly done ventilation decreases fire spread and increases visibility for fire attack, aids in life safety, speeds fire attack, aids in fire spread control, reduces the potential for flashover and backdraft, and helps with property conservation. Inadequate or improper ventilation can cause death or injury to fire victims and firefighters and cause destruction of the building. Before ventilation can be started, officers must make numerous decisions based not only on fire conditions but also their experience and knowledge.